Everyone, in this video I will discuss about rest and motion. A particle is said to be at rest if it does not change its position with time, and in motion if it changes its position with time. The position of particle is measured with respect to a specific stationary or moving coordinate system called frame of reference. A particle stationary in one frame may appear to be moving in some other frame of reference. Now let's discuss about position vector. The position vector represents location of any particle in space with respect to any coordinate system. Here I have drawn a two-dimensional Cartesian coordinate system and located a particle at any point P in the plane. Its position vector with respect to the given coordinate system is the vector r, and at point Q the position vector is r plus delta r. Now let's discuss about displacement. Displacement is obtained by subtracting the initial position vector of particle from the final position vector. Displacement of particle in time delta t, in which it has moved from point P to Q, is vector pq, and this vector is obtained by subtracting the position vector of point P from the position vector of point Q, that is vector r plus vector delta r minus vector r equals vector delta r. Now let's discuss about infinitesimal displacement. If you take the limit delta t tends to 0, the delta r term will become dr, and this is called the infinitesimal displacement of the particle in time dt. Now let's discuss about distance. Length of the path traveled by an object in fixed time duration is called distance. Distance traveled by particle in infinitesimal time is ds, and it is the modulus of the infinitesimal displacement. The distance traveled by a larger time duration delta t can be obtained by integrating the infinitesimal distance along the curve in which the particle has traveled. Now let's discuss about average velocity and instantaneous velocity. Suppose a particle moved from P to Q. The displacement of this particle will be vector pq, and this will be equal to delta r. So the average velocity of this particle can be obtained by dividing delta r with delta t, and the instantaneous velocity can be obtained by taking the limit delta t tends to 0, delta r upon delta t, and this is written as dr upon dt. Now let's discuss about average speed and instantaneous speed. Average speed of the particle can be obtained by dividing the total distance traveled with the total time duration taken by the particle to travel the distance. So VAB equals S upon delta T is the average speed. Now let's discuss about instantaneous speed. Instantaneous speed is the modulus of instantaneous velocity vector of the particle. Now let's discuss about average acceleration and instantaneous acceleration. Average acceleration is a vector quantity, and it can be obtained by dividing the time duration to the velocity change. The instantaneous acceleration is obtained by taking the limit delta t tends to 0, delta v upon delta t. This is written as dv upon dt. Let's discuss about motion along a straight line in one dimension with constant acceleration. A particle is moving along a straight line in one dimension with constant acceleration. We have assumed that the direction of the particle is along positive direction of x-axis. In such a scenario, we can assume the vector uv as along the x direction, and acceleration is also along the x direction. So we can write vector u equals ui cap, vector v equals vi cap, and vector a equals ai cap, and the displacement of the particle x equals to xi cap. So using the formula of acceleration, a equals dv upon dt, and if we integrate by taking the component along x direction, we will get a scalar equation a equals dv upon dt, and we can again get dv equals a dt. On integration with respect to dt, we will get the integral of dv from the limit u to v equals a times integral of dt from the limit 0 to t. This integration will give v minus u equals to a times t minus 0, and if we take all the terms in right hand side, we can get v equals u plus at. Now using the definition of instantaneous velocity, we can write dx upon dt equals v, and v we know that the value of v is u plus at, so dx upon dt equals u plus at. On multiplying dt both side, we will get dx equals u plus at dt, and on integration we will get integral dx 0 to x equals integral u plus at 0 to t. So we will get x equals ut plus half at square. And next we can obtain the relation between the velocity v, u and the displacement x. We know that from first equation that t equals v minus u upon a, and the velocity term v minus u upon a can be put to the equation x equals to ut plus half at square. If we put the value of t in this equation, we will get x equals to u multiplied by v minus u upon a plus half a multiplied by v minus u upon a whole square. On simplification, we will get x equals v square minus u square upon 2a. And on further simplification, we will obtain v square minus u square equals 2ax, and v square equals u square plus 2ax. Now let's discuss about motion along a straight line in horizontal plane. In this motion, we have assumed that the particle is moving along a straight line in any orbit direction. So the motion has the parameters acceleration, velocity and displacement, and all these parameters have two components. The acceleration a has two components, ax and ay, and the velocity v has two components, vx and vy, and the displacement r has two components, x and y, along the x direction and along the y direction. So we can write the kinematic equation for constant acceleration along straight line for both the component x component and y component. For x component, if we write the equation, we will get vx equals to ux plus axt, and the second equation x equals to uxt plus half axt square, and third equation vx square equals ux square plus 2axx. And if you consider the y component, we will get vy equals ui plus ayt, and y equals uit plus half ayt square, and vy square equals to uy square plus 2ayy. So these are the 6 equations we will get to obtain the different variable between the u, v and a.